Hi explorers, and welcome back to another neural network series video. And last time we talked about the softmax layer, and the layer before the softmax layer is this fully connected layer. And let's see, is it in the pool? No, it's not in the pool. It's not a normalizer. Yes, might not have that one open, of course. It should be in... Is it in the drop? Yeah. So this is the fully connected layer, and that's could be the reason why the number of clauses isn't used in the softmax layer, because this fully connected layer builds the number of outputs that the softmax layer needs to operate. So that could be the reason. So in this function we have here, we set the output depth to the number of neurons, and then we have a number of inputs, and we have a flat structure. We don't have any volume, it's just a row of values, and we have some bias here, and this value is taken and set to 0.1, and that comes from the logic in the network from the creation here. So you have, depending on which layer comes first and in what order you create this, you should either have a bias of 0.1 or 0. And in my case, we have this ReLU activation, so then we will get a 0.1 value as a bias. So that's why I add that. But in this case, let's see here on the convolution and if we have an activation. But I think on the fully connected layer we don't have any activation. So in this case it should actually be 0.0. So we found a bug there. Good. So let's continue here. We're looking at this fully connected. Pretty much translated everything. These are optional, so I removed those. They aren't used in this layer at all, so why have them? And we have some computed values, and this layer type isn't used either, so I removed that. I set the bias, create the filters, and create the bias and set the output. We have seen this before. The forward layer, very easy as well. We just have this for loop here that goes through the depth and the number of inputs, and we calculate a filter here. We get the filter weights and add the filter weights to the input weights on the different positions. So that's pretty much it. We have seen this function before in other implementations. So this is just a simple translation of this JavaScript. And here we have the back propagation, where we create a gradient for a new layer for the input layer, and also for this TFI, where we set the gradient. And I guess that's the filters gradient that we change. So I don't understand this code yet, but hopefully when we have translated and then look into how these different things work, we change names and so on, it could become clearer for us. I'm learning by writing code, getting it to work, and then go backward and actually translate the different things so I get a better picture of how it works. This translation of the backpropagation we have seen before, so that's not interesting to look more at. We can look at the pooling layer as well, see if there's anything interesting here. We have some optional values that is not, some are used, some are not. So I removed the stride, which is not used in this pooling layer. We have 2 stores of switches. So these are int positions of values that we want to switch out, I guess. And yeah, we store the output size as well. We, on our forward loop, we will calculate these win X and win Y, and those are the switches that we put here. And on the after this implementation and setting this new weight on the back propagation, we will actually use these arrays with switch X and switch Y to figure out where to put the gradient on the back propagation. So that's how the pooling layer works, the little things that I have found out of the pooling layer so far. We will probably get more about that later on. See here, normalization. Was this local normalization layer? That weird name that I couldn't remember. And I see if I can get it on the right side. There we go. Close this up again. See if we have any specific things to talk about. Yeah, these are interesting. I actually, when I implemented this, found out that I needed a K, an N, an alpha, and a beta, and those were never mentioned in the JavaScript code. I looked a lot for them, and I couldn't find any values anywhere that they should set these values anywhere. As we see here, they have some standard values, but no, those are not. K is set to 0 here. Okay, and beta 1 and beta 2 are set, but we actually have the input of K and N and alpha and beta, and later on in the implementation here we can see that we use beta 1, beta 2. Let's see if I can find alpha. Okay, don't see alpha. That's weird. Could have sworn that I had alpha used in the code here. Weird. Anyway, I actually looked these up in order to use them. No, I look in the trainer. Oh, that's why. Here we see that we have required values K, N, alpha, and beta. Now we are back in business again. And these required fields are never set. I searched through all the GitHub code for the name alpha, and alpha is never mentioned. So I don't know where they set these values in their code, but I found this research paper here for the ImageNet, and they talked about these values and what they are. They are hyperparameters that you could set to different values in order to get this normalization layer to work. And the suggested values were 2, 5, 10 up to 10 up. I don't really know how to say that in English, but yeah, 0.0001, and then you have beta to 0.75. So these are just constant values that you can fiddle with back and forth. Those were never mentioned in the JavaScript code, but I set them from this paper and hope that that's good enough. And then we have this in, out, and scache that we use. We define the computed values. In this case, we should also set the output values, right? I always do that, so why not do it here? Let's add that. That's a bug. I find a few bugs here while we go through this code. That's good. It's one of the reasons to do this, to look closely at that. So now we have set that, so we have some output definition. Then again, we get the output values from the definition, so that's not needed. Sorry. And the forward loop here is a bit strange. In the JavaScript code, we do the first setup here. That's pretty much the same as we have here. We go through the full volume. Nothing strange about that. We get the first weight, and then we will calculate this den value. So that's what we have here. And then we will time that with alpha divided by n and add k, and set that to our cache. And we will do with the power of beta and set that value, den value, divided by AI, which is our input vector. And I can't see really that we use this AI value anywhere else. So this is some value to get this normalized. Very strange math here, but it's pretty much the same as we have over here. And I guess this scache makes the value. No, we will save the value so we can use it in the back propagation, I guess. Yeah. So here we see that we get that value back. So here we will create the input vector. We have an output act, and then we just do work on the input. So the output is never used. That's a bit weird. That's because I have done no. So do we use A? Doesn't look like it. Let's see if we can have any A dot. Nope. So A is never used here, so we can remove that in the backward propagation. Good to know, good to know. And we run this through, and let's see here, run this through the full volume again, and we will calculate the normalization gradient using this scache. And this math is also something that I will have to look into more later on it's just translated back or to Java. So let's see here, do we have anything in the network that we want to mention? Yeah, so this create we have this function here, make layers. I'm not using that at all at the moment, so this make layers is disregarded. I will set up my full network by hand. Then we have some helper functions here to do the forward propagation. Pretty easy, cost loss, never used so far. Backward propagation, just run through the different layers, but we do something different with the first layer because, or the last layer, there we actually set the correct value. So that handled a bit differently. So in this case we require that the last layer is a loss layer. And then we have this back propagation result. It just accumulates all the different back propagation results. And we have some prediction that we don't use at the moment. I guess that could be interesting to know later on if we want to see what value is actually correct one. So let's see here. We have the mystery that we have already talked about. The test class we saw earlier. The difference here is that I actually added this misreader, and I have a for loop where I do the actual training, and I will print the current training results. So I will see how much better the actual network will get over time. That's the idea, at least. Let's see if we can come to that later on. At the moment it doesn't work, so I have some debugging to do. The training interface, very simple as well. Train something, get a training result. So not much to look at. And this ADA grade trainer is one of the trainers specified here. In order to do training, we need a lot of data values. We need a list of the different summations. We need a learning rate. We need some decay, a batch size, and so on. And everything is set in different values here. In this trainer here you set a few more values, but that's because other training methods require more or less data. So depending on what kind of trainer we get, we need a different set of data. So that's why. And this training function is also translated straightforward. We have, this is the forward loop with the time calculation, so we see how much time it takes. This is the backward loop, also with the time. So both of these are pretty much the same, just translated straight through. And we see here that we get a cost loss that we will have later, so we can see how much better or worse we're doing. And then we have this very strange regression. I guess that one of the loss or the loss function is regression, and in that case you could use a full data block as your training data or your result. In my case I'm not doing that at the moment, so I've removed that logic because it's confusing. And then we will go through and handle batch sizes. I'm not sure if this is needed, but that's if you want to run forward and backward propagation over a number of different images before you actually change your gradients and improve. So you will get more data before you do changes, I guess. Or is this just to get some output? Could be as well. So here we will get the backward propagation result. We do a lot of summation here. Then we will get all the weights and get all the learning decay parameters, and go through here and sum up even more data, and then we will return a lot of different information in this training result. And the training result is just setting this information and then printing some of this. So it's not that fun either. So I think that I've talked extensively about pretty much everything that I've implemented so far. Some of it is very clear and some of it is still a mystery for me. And I think when I go in and debug it, and when I find out that what works and what doesn't, I might get a clearer picture. And when I get a clearer picture and understand things more, I'll try also to do some changes in the naming of stuff so it will be easier to read. And I might change a few of the names that I use so far. But I'm very curious to see what your thoughts are about this project. What names do you think are appropriate to use in the different blocks and so on? And have you played around with this before? Yeah, give me your thoughts, your likes, your comments, everything. I want to do this with you. I want to learn about convolutional neural network, and every comment and every suggestion and discussion that I can have with you will make my process better, and I will learn a lot about learn a lot from it as well. So please go in and converse with me. I will answer all of the comments, and I read all of them. So yeah, I hope to see you in the comment thread. I hope to see you in the next video. I will go and debug this and try to get it working, and also do some tweaks here and there, and then I will do another of these update videos and talk about how the new network is. So I really hope to see you in the next video.